All right, let's dive into software security. We've got some definitions and a pretty cool diagram to help us out. By the time we're done, you'll be speaking security like a pro.
Think vulnerabilities, testing methods, the whole shebang.
Exactly. We'll even see how those hacker-in-the-movies tricks can actually happen.
Because let's be real, it's not just Hollywood.
Nope, this is about the software you use every single day. Speaking of real world, let's start with this diagram about code injection attacks. Sounds scary, right?
Oh, it can be. It's all about how a hacker can sneak malicious code into a program.
Like messing with a recipe to change the outcome.
Pretty much. Instead of a delicious cake, you get a nasty computer virus.
Yikes, I'll pass on that recipe. The diagram shows binary and source code attacks. What's the difference?
It's about the levels hackers target. Binary code is what your computer actually understands. Source code is what programmers write, the human-readable version.
So attacking binary code is like hitting the computer's core, while source code is more like going for the blueprint?
You got it! And the impact can be huge. Take stack smashing and heap smashing attacks. They mess with how a program uses its memory.
Sounds dangerous.
It is. They can overwrite important code, cause crashes, even give an attacker control.
Hold on, so it's not just about stealing data. They can take over my computer.
It's a real possibility. And then there are the source code attacks.
Those sound equally sneaky.
They target different programming languages. You've got dynamic language attacks focusing on languages like JavaScript, often used for websites.
Makes sense.
And domain-specific language attacks, which go after languages for specific tasks, like SQL for databases.
So each language has its own weak spots.
You could say that. That's where abstract syntax trees, or ASTs, come in. They analyze code for weaknesses by breaking it down.
Like an X-ray for security, finding hidden vulnerabilities.
Perfect analogy. Now let's zoom out a bit. Let's talk threat modeling frameworks.
Okay, threat modeling. Sounds intense.
It's about systematically finding and analyzing potential threats to a software system. Think of it like trying to be the attacker, finding weak points before they do.
A preemptive strike against vulnerabilities. We've got definitions for stride and dread. Those sound familiar.
They're widely used, and each has its own approach. Stride categorizes threats by their type: spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege.
That's quite the list. Stride seems pretty thorough.
It covers a lot of ground. Then there's dread, which focuses on how bad a threat could be. It stands for damage potential, reproducibility, exploitability, affected users, and discoverability.
So dread is about prioritizing threats by their potential severity, not just their type.
Right on. Both frameworks are useful. It just depends on the software and the situation.
It's like anticipating the what-ifs before they become a real problem.
Exactly. Which brings us to testing methodologies. Here's where the attacker's view and the defender's view clash.
Okay, time for some detective work. We've got black box, gray box, and white box testing. Fill me in.
Think of these boxes as how much the tester knows about the system they're looking at. In black box testing, they know nothing, like an attacker trying to break in blind.
So trial and error, seeing how the system reacts.
Yep. Then there's gray box, where they have some information, maybe design documents, but not the whole picture. And finally, white box, where they have full access, source code, architecture, everything.
So the more you know about the system, the more targeted your testing can be.
Exactly. And these approaches lead to two big testing concepts: static and dynamic analysis. Static analysis is like proofreading code, checking for errors without running it.
So it's preventative, catching vulnerabilities before they go live. What about dynamic analysis?
Dynamic analysis is about testing the software in action, watching it work in real time.
Like taking a car for a test drive, seeing how it handles?
That's the idea. Now let's switch gears and talk about how security is built into the development process itself.
All right, development time. We've got Waterfall and Agile. How are they different, and how does security fit in?
Waterfall is linear, step by step. Requirements, design, implementation, testing, deployment, and maintenance. Security is usually addressed up front, but testing often comes towards the end.
Seems organized, but a bit rigid. What if you find a vulnerability later on?
That's where Agile shines. Agile methodologies like Scrum are all about flexibility and iteration. Development is broken down into smaller cycles, allowing for constant feedback and changes.
So Agile allows for ongoing security integration instead of waiting till the end.
Precisely. It's about building security in from the very beginning.
A more proactive and adaptable approach then.
You got it. And this leads to DevSecOps, where security is a part of everything from development to operations.
DevSecOps, so it's not just a separate security team, it's everyone's job.
Exactly. Speaking of people, let's talk about the key players in software security. One that stands out is the software security champion.
The unsung heroes, what do they actually do?
Imagine them as the security advocates within the development team. They're passionate about security, always learning, and pushing for secure coding practices.
They're like security evangelists, spreading the word and making sure everyone's on board.
Right, and they're not alone. You've got organizations like NIST and OWASP setting standards and providing resources.
NIST, the National Institute of Standards and Technology, they set guidelines for all sorts of technologies, including software, right?
That's right. Their cybersecurity framework helps organizations manage and reduce cyber risks.
What about OWASP? Where do they fit in?
OWASP, or the Open Web Application Security Project, is all about web application security. They're famous for their OWASP Top 10 list of the biggest security risks for web apps.
The OWASP Top 10, every developer's guide to what to avoid.
Precisely. But finding vulnerabilities is just the start. Managing them effectively is an ongoing process called vulnerability management.
Let's talk about that. What are the key parts?
First, you've got common vulnerabilities and exposures, or CVEs. It's basically a global list of publicly known security vulnerabilities.
So it's a way for everyone to be on the same page about weaknesses.
Exactly. Each vulnerability has a unique CVE ID, so it's easy to track and share info. And to prioritize fixes, there's the Common Vulnerability Scoring System, or CVSS. It's a standardized way to score how bad a vulnerability is.
So CVSS helps decide which vulnerabilities need to be fixed first.
You got it. Now, we've covered a lot, but this is really just the beginning. There's a whole world of details out there.
I'm ready to dive deeper. But for now, let's take a break and let all this sink in. In the next part, we'll get into the specifics of vulnerabilities and explore the tools and strategies used to protect software. Stay tuned.
Welcome back to our software security deep dive. Last time we got a handle on those core concepts, things like code injection, threat modeling, and all those testing methods.
There's a lot to take in.
It was. But now we're going to explore some real-world vulnerabilities, the stuff that actually keeps software security folks up at night.
Okay, let's expose those hidden threats. Where do we start?
Let me jump right in with SQL injection. It's a big one in the web app world, all about messing with a website's database.
SQL injection, like straight out of the movies? How does that actually work?
Think of a website with a login form, right? Behind the scenes, it's using something called SQL queries to check your info against its database.
Okay, so far so good.
Now imagine an attacker sneaking in malicious SQL code into that username or password field. If the website isn't careful about cleaning up user input...
That code can slip right in.
Exactly. And then boom, things can get messy.
What kind of messy are we talking?
The attacker could bypass the login, grab sensitive data like credit card numbers, even mess with the database itself.
That's a major security breach. Makes you think twice about entering info online.
Definitely makes you think. So how do developers prevent this? Well, one way is using parameterized queries. It's a fancy way of saying they treat user input separately, so it can't be interpreted as code.
So it's like a security checkpoint, filtering out the bad stuff.
That's a great way to put it. And then there's input validation, double-checking that user input is what it's supposed to be.
Right. If a field is supposed to be a number, then only numbers allowed.
Exactly. Being proactive and thinking like an attacker is key here.
So it's like a constant back and forth attack, defend, attack, defend.
In a sense, yeah. And regular security testing is crucial too. Things like penetration testing, where ethical hackers try to break in.
It's like a security team's training exercise, right?
Exactly. They're finding weaknesses before the bad guys do.
Okay, what else is out there in the world of vulnerabilities?
Well, let's move on to cross-site scripting, or XSS. This one is different. It attacks the user's web browser.
So not the server or database, but what I see on my screen.
Exactly. Let's say a website allows comments, and an attacker injects some malicious JavaScript code into their comment.
JavaScript. That's pretty common for making websites interactive, isn't it?
It is. But like any tool, it can be misused. If the website isn't careful, this code can run in the browser of anyone who sees that comment.
Hold on, so just by viewing a comment, I could be in trouble?
It's possible. This code could steal info like cookies, those little files that store your login details.
Oh!
Or even redirect you to a fake website that looks real, a phishing site.
That's scary. So what can be done about XSS?
Similar to SQL injection, input validation is super important. And there's output encoding, which changes special characters so the browser doesn't run them as code.
It's like neutralizing the threat before it even reaches my browser.
Exactly. Developers really need to be careful with user input. It's often how these attacks happen.
It's like user input is the gateway. Got to keep it secure.
Exactly. Now let's shift gears again. Have you heard of cross-site request forgery? We call it CSRF for short.
CSRF. I can't say I have.
This one takes advantage of the trust a website has in your browser.
Okay, I'm intrigued but a little confused. How does that work?
Let's say you're logged into your bank's website, right? Then you visit another site, a malicious one, and it secretly sends a request to your bank's site.
A secret request? Doing what?
It could be anything, like a request to transfer money from your account.
Wait, just by visiting a website? That's a bit unsettling.
It is. If the bank's site doesn't have the right protections, that request could go through without you knowing.
Oh, man. I'm starting to realize just how important it is to understand this stuff.
It is. So how do we protect against CSRF? One common way is using CSRF tokens. They're like unique secret codes the server adds to each request.
So the server can verify the request is actually coming from me.
Exactly. Another way is by checking the HTTP referer header.
The what header?
The referer header. It tells the server where the request came from.
Gotcha. Another way to make sure everything is legit.
Now, let's move on to something that sounds a bit like espionage, directory traversal.
Okay, that one sounds interesting. What's that all about?
This attack exploits flaws that let attackers peek into files and directories they shouldn't have access to.
Like trying to break out of the website's boundary.
Exactly. Say a website lets users download files. An attacker might manipulate the file path to access sensitive system files.
Oh, like what kind of files?
Configuration files, application code, even files with passwords or API keys.
That sounds like a recipe for disaster.
It can be. Developers need to be careful with input validation, sanitization, and how they configure web servers.
So it's all about keeping users in their lane, only letting them access what they're supposed to.
Right. And another key principle is least privilege, which we talked about before.
Right, giving users and programs just enough access to do their job and nothing more.
Exactly. It minimizes the damage even if an attacker does find a way in.
Makes sense. Like the less they can access, the less harm they can do.
Now remember, these are just a few examples. There are many more vulnerabilities out there and new ones popping up all the time.
Sounds like it's a never-ending battle.
You could say that. But with the right knowledge, tools, and a proactive approach, we can stay ahead of the game. Which brings us to security tools and best practices for creating secure software.
Okay, let's open up the security toolkit. What kind of weapons do we have in the fight against vulnerabilities?
Well, one of the most important concepts is the Security Development Lifecycle, or SDL.
SDL, that rings a bell. Remind me what it's all about.
It's a way of thinking about software development where security is built into every single stage, from the very beginning all the way to the end and beyond.
So it's not just an add-on, it's baked into the whole process.
Exactly. And one of the key parts of SDL is threat modeling, which we talked about before. It's about finding potential threats and weaknesses early on.
Right, like making a security blueprint before even writing any code.
Precisely. Another crucial part of SDL is secure coding practices. It's all about teaching developers how to write code that's tough to crack.
So it's like learning to code with security in mind from the start.
Exactly. Organizations like OWASP and NIST have tons of resources for this, things like secure coding guidelines and checklists.
Sounds like those organizations are doing important work in helping developers build secure software. What else is part of this SDL?
Security testing is a huge part. Remember we talked about different testing methods like static analysis, dynamic analysis, and penetration testing.
Right, like having a team of experts poke and prod the software looking for weaknesses.
Precisely. And this isn't a one-time thing. Security testing should be part of the entire process.
So it's like regular checkups to make sure everything is still secure.
You got it.
Oh.
And then there's vulnerability management. That's about having a system for tracking and fixing vulnerabilities when they are found.
So it's like a rapid response team for security issues.
That's one way to think about it. Now, let's get to the tools themselves.
All right, I'm ready to see what security pros use to keep our software safe.
Well, one category is static analysis security testing tools, or SAS tools for short. They look for potential problems in the code itself without actually running the software.
So it's like a code detective, looking for clues that something might be wrong.
That's a great way to put it. These tools can scan tons of code quickly, pointing out areas that need a closer look.
Sounds incredibly efficient.
It is. There are lots of great SaaS tools out there like SonarQube, Fortify, and Checkmarks. Each has its pros and cons, so you got to pick the right tool for the job.
Makes sense, just like any other tool.
Now, besides SaaS tools, we've also got dynamic analysis security testing tools, or DAST tools.
DAST, right. How is that different from static analysis again?
Well, remember, SaaS looks at code at rest. DAST looks at it while it's running, interacting with the software like an attacker would.
So DAST is more about simulating real-world attacks, seeing how the software reacts under pressure.
Exactly. They can find vulnerabilities that might not show up in static analysis, like problems with configuration or authentication.
It seems like SAST and DAST are a powerful combo, giving a more complete picture of security. Anything else we should know about?
Absolutely. There's also interactive application security testing, or IST tools.
IST. Okay, now I'm really curious. How are those different?
Think of them as a mix of SAST and DAST. They work from inside the application, monitoring it in real time.
So like having a security guard stationed inside the application, keeping an eye on things.
Precisely. They can provide more accurate information about vulnerabilities because they see the code and how it's behaving.
This is also fascinating. Software security is really a multi-layered thing.
It is. It's not just about writing good code. It's about a whole mindset, a way of approaching software development from start to finish.
And it sounds like it's a never-ending process.
You could say that. The world of software security is always changing. New threats, new vulnerabilities. It's a constant evolution.
So staying up to date is crucial.
Absolutely. But with the right knowledge, the right tools, and a proactive approach, we can stay ahead of the curve. And that's what makes this field so exciting.
I'm ready for more. What else do you have for us?
Welcome back to our software security deep dive. We've been through a lot, from code injections to threat modeling, even diving deep into specific vulnerabilities like SQL injection and XSS.
It's amazing how much there is to learn, right? Building truly secure software is a complex process. Definitely. It's not just about knowing a few tricks. And that's where I think the idea of a software security champion is so important. Having someone on the team who's really passionate about security can make a big difference.
It's like having an internal advocate, someone who's always learning about the latest threats and encouraging their colleagues to code with security in mind.
Right, making sure everyone's on the same page. And of course, there are organizations like NIST and OWASP that provide invaluable resources.
Those organizations play a crucial role. NIST has the cybersecurity framework, which is super helpful for organizations trying to manage and mitigate risks.
Right, and OWASP is famous for their OWASP Top 10 list of the most critical web application security risks.
It's a must-read for any developer. But of course, finding vulnerabilities is just the first step. We also talked about all those amazing security tools, both static and dynamic analysis.
Yeah, it's like having a whole arsenal at your disposal. But with so many options, it can be hard to know where to start. If someone wants to improve their software security practices, what's a good first step?
Adopting a security development lifecycle, or SDL, is a great place to start. It's about baking security into every stage of development.
The SDL, right? We touched on that before. It's about shifting your mindset, thinking about security from day one.
Exactly. And the great thing about the SDL is that it can be adapted to fit different situations.
So it's not one size fits all.
Nope. The specific SDL practices and tools that work best will depend on the type of software, the organization's risk tolerance, and even industry regulations.
So tailoring the approach is key. But are there any general best practices that apply across the board?
Absolutely. Defense in depth is one of the most fundamental. It's about using multiple layers of security.
So not putting all your eggs in one basket.
Exactly. Imagine trying to break into a castle. It's much harder if there's a moat, outer walls, inner walls, guard towers. You get the idea.
Makes sense. The more obstacles, the better.
Right. And then there's least privilege, which is all about limiting access.
Right. Give users and programs only the access they absolutely need.
Exactly. It minimizes the damage even if someone does manage to exploit a vulnerability.
It's like that old saying, better safe than sorry.
Exactly. This has been such an insightful deep dive. We've covered so much ground, from different types of attacks to threat modeling, testing, specific vulnerabilities, and the tools and best practices that keep our software safe.
It's been amazing. I feel like I've learned so much about this complex and ever-changing world.
You now have a great foundation in software security concepts. But remember, this is just the beginning. The security landscape is constantly evolving, so continuous learning is essential.
Absolutely. So what are some good resources for staying up to date on the latest threats and best practices?
Websites like OWASP, SANS Institute, and the National Vulnerability Database are great places to start. And there are tons of security conferences and workshops where you can learn from the experts and network with other professionals.
It's like having a global security community at your fingertips.
And that community is so important. Software security isn't just about technical solutions, it's about people working together.
This deep dive has been incredibly eye-opening. It's made me realize just how crucial software security is in our increasingly digital world.
It's something we all need to be aware of, both as developers and as users.
So as we wrap up this deep dive, remember, knowledge is power.
And in the world of software security, that power can help us build a safer and more resilient digital world.
Thanks for joining us on this deep dive into software security. We hope you learned a lot, and until next time, stay curious, stay vigilant, and stay secure.